Now, another type of one-pipe system is the loop system. And the loop system comes about with the invention of baseboard, which is pretty much attributed to Mel Dubin, who founded the Slanfin Company when he came back from World War II. And that was on Long Island, not far from where I live. And Mel told me once that he decided to position his company right there because he wanted to be as close to Levittown as he could possibly get. And I'll tell you about Levittown later, but that's where they did 17,000 radiantly heated houses, tubing going into the slab. And Mel had a feeling that that stuff was going to fail over time, and it did. And Mel wanted to be real close there with his baseboard. So he did okay, and he was a great guy and a good friend, and I miss him very much. Passed away recently. So with the loop system, we're taking this pumping away idea, and we're going through a continuous loop of baseboard back down. So it takes a lot of the thinking out of it. But what you have to be careful about is there are limits to how far you can go on baseboard loops before you run out of heat. So the rule of thumb for this, based on the manufacturer, is never go beyond 25 feet for half-inch baseboard and never go past 70 feet for three-quarter-inch baseboard. Otherwise, you're going to have a problem. So one time I was doing a seminar, and a guy comes up to me during the break, and he says to me, Dan, he says, I put this baseboard loop into this big VFW hall where they got this big area that they rent out for parties, and then it goes to offices. And I got this one big loop, and I can't seem to get the end hot where it goes to the offices. I said, well, what have you been doing? He says, well, I've been bleeding it. I said, of course you have. And I said, when you bleed, do you get any air? He says, no, that's the damnedest thing. I don't get any air, but I keep bleeding it. I said, well, if you don't get any air, it ain't an air problem. Why are you bleeding it? He says, well, what else am I supposed to do? I said, well, how many feet of baseboard element do you have on that one circuit? He says, well, all in all, it's about 375 feet. I said, you got 375 feet of three-quarter-inch fin tube on one circuit. You want to know why the end is cold? He says, yeah. I said, the end is cold because you ran out of heat. You can probably chill meat with what's coming through that radiator at that point. You ran out of heat. He says, how could I run out of heat? Everything's connected. The circulator's running. How could I run out of heat? So I said to him, let me see if I can make this visual for you. And let me see if I can make this visual for you. I said, imagine a British thermal unit as a little man who lives in the boiler and works in the radiator. And he's a little British thermal unit. So he's wearing a raincoat and a bowler hat, and he's carrying an umbrella, and he's got a briefcase, and he's the heat. And he lives inside the boiler, and he goes to work in the radiator, and he travels to work on this thing we call the flow rate. That's the water flowing through the pipe. Guy says, I like this. I could see this in my mind's eye. So I said, okay, now since it's a three-quarter-inch pipe, we don't want to move more than 4 gallons per minute through that, because otherwise you're going to get a lot of noise. And the baseboard people tell you no more than 4 GPM. That's it. So now if it's 4 gallons per minute, if we're working with a 20-degree temperature drop, the water goes out at 180, comes back at 160, giving us an average water temperature of 170. That means that each GPM is 10,000 BTUs. That's what it can carry. So since we got 4 GPM, that means that we got 40,000 guys that are going to go to work. He says, I like this. I could see this. I said, great. Work with me here. So the train starts up, and the 40,000 guys, they get on the train, and they head out into the baseboard. Now they're moving into baseboard element that has air moving across it. So that's like getting off the train. So every linear foot that they travel, about 600 of these guys hop off the train. That's where they work. They're going up to their office. So every 600 BTUs come off every foot. So by the time you get past 70 feet, you're basically out of guys. You don't have any more guys. The train's going, but there's nobody on it. That's why you don't have any heat. The guy says, wow, I like that. I can really see that in my mind's eye. I said, okay, so now you know what you got to do, right? He says, yeah, I got to get a bigger circulator. So I said, there's nobody on the train, and you're looking for a bigger locomotive. You want to bring nobody there faster. So, no, that wasn't the answer, bigger circulator. But the answer was, of course, to split the zone up into zones that are no longer than 70 feet, which is what he had to do. And again, he says to me, well, who's supposed to pay for that? And I said, well, you are. He says, why should I pay for it? I didn't know. I said, because it's tuition. Now you know. This is the price of learning about this stuff.